Now we will split structures into separate categories and analyze each type in greater detail. First, we will look at beams and columns. Beams are usually horizontal members that carry forces in bending. We draw them using horizontal straight lines or rectangles. When we represent a beam with a force being applied on it, we draw the beam to depict bending, as shown. Although this drawing is exaggerated, it provides the general idea of how a beam carries forces. Again, we can draw with either straight lines or rectangles. On the next slides, we have a couple examples of beams we can analyze. This first example shows a wooden structure. Take some time and pause the video here and identify how many types of beams are in this example. The first type of beam is the joist, running horizontally along the structure, which I have colored in red. The second type of beams are the wooden planks resting on top of the joist, that are colored in purple. So there are two types here. If we were to analyze how these two types of beams carry forces, we can imagine that each of the wooden planks applies a load to the horizontal joist, and the joist then distributes that load to the columns and into the ground. In this picture, see if you can identify how many types of beams are present. The first is the large structural beam outlined in red. The second are the thinner perpendicular beams on top of the structural beam, which are outlined in purple. And the third type of beams are the wooden planks that make up the roof and rest on the second type of beam, which I have outlined in green. So, there are three types of beams shown in this example. Now, to get an idea of how these beams would transfer a load, imagine that there is a load acting at the yellow X in the picture. If a load was applied here, the green wooden planks would first take the load and transfer it to the purple beams. Those purple beams would then transfer the load to the large structural beam in red, which would distribute the force even further. Columns are vertical members that carry forces in compression. We draw them using vertical straight lines or rectangles. When we represent a column with a force being applied on it, we demonstrate compression with a shorter line, and you can clearly see this with the before and after compression drawings. Although this drawing is exaggerated, it provides the general idea of how a column carries forces. Again, we can draw with either straight lines or rectangles. On the next slides, we have a couple examples of columns we can analyze. Pause the video and see if you can determine where the columns are. The structure is the Athena Parthenon, and here we have a roof structure supported by a multitude of columns. I have highlighted a couple of the columns in purple here. Now, to get an idea of how these columns would support a load, consider the roof structure on top of the columns colored in green. The load of the roof applies a downwards force onto the columns, which then distributes the forces downwards into the ground. The columns carry these forces through compression, as we have just learned. The next structure we're going to analyze is the Millau Viaduct. Pause the video here and see if you can determine where the columns are. This is a bridge structure supported by large columns. I have highlighted a couple of the columns in purple. To get an idea of how the bridge distributes loads, consider the weight of the deck, highlighted green, that can be considered a distributed load, and acts downwards on the columns. The force travels downwards through the columns, which carry these forces by compression.